Today we are learning about solutions, which is when something is dissolved in a liquid. First of all, this is how an ionic compound dissolves in water. Water is polar. It has a positive pole and a negative pole, a positive end and a negative end. The oxygen is negative and the hydrogens are positive. This is because oxygen tends to want to have a negative charge and hydrogen tends to want to have a positive charge. But it doesn't have a complete charge because it's not ionic. It's a molecule which is made of both nonmetals. So instead of being a full positive and a full negative, it's a partial positive and a partial negative. That's what this little Greek letter delta means, partial positive and partial negative. So we have salt, NaCl, dissolving in water. And the positive hydrogen ends of water are attracted to the negative chloride ion in the salt. And the negative oxygen end of water is attracted to the positive sodium ions in the salt. The water molecules surround the chlorides and surround the sodium ions, and they wrap around them and pull them off into the solution, and that's how it dissolves. Not only does it dissolve, but it also dissociates. Sodium chloride breaks up into sodium ions and chloride ions. It's dissonant because I don't want to associate with it, speak to the hand. All right. But anyway, that's what dissociating means, breaking up into ions. Next, something will dissolve in water because it's polar or ionic. And the polar, the positive and negative poles, will attract the other positive and negative poles, or the ionic ions. And opposites attract. So the positive hydrogen attracts the negative chloride, the negative oxygen attracts the positive sodium. You have to have these opposite attractions in order for something to dissolve. Nonpolar molecules do not have a positive and negative pole. Therefore, they do not dissolve in water because there's no positive and negative to attract the water. Oil is a nonpolar molecule, and oil does not dissolve in vinegar because vinegar is polar. So the rule is like dissolves like, which means polar dissolves polar and nonpolar dissolves nonpolar. Two substances are insoluble, they do not dissolve when there is a lack of attractions. There's no positive and negative to attract. When you have something dissolving in water or dissolving in anything, you have a solute, a solvent, and the whole solution. The solute is the thing that gets dissolved. For example, in salt water, salt would be the solute. The solvent does the dissolving. Hear that? See how that'll help you remember? The solvent does the dissolving. And in salt water, water is the solvent. It dissolves the salt. And the saltwater solution is the whole thing. The salt plus the water, the solute plus the solvent makes up the solution. We've all heard of a saltwater solution. That's actually correct. Solubility is the maximum amount of solute that dissolves in a given amount of solvent at a given temperature. In other words, it's how much will dissolve. That's the solubility. So the amount of salt that dissolves in water is the solubility of the salt. Now what about the rest of that junk? What about dissolves in a given amount of solvent at a given temperature? Well, you know that, let's say we have sugar water, all right? You know that sugar dissolves really well in hot tea and not so well in iced tea. You can dissolve more sugar in hot tea and less in cold. And so we have to specify what temperature your liquid is, your water is, because otherwise you could dissolve more or less sugar. We also have to specify the amount of water we have, because the more water we have, the more sugar we can dissolve. And so that's why you have to specify how much liquid and what temperature is it. Otherwise you could dissolve a different amount. Next we're going to talk about an unsaturated, a saturated, and a supersaturated solution. An unsaturated could still dissolve more solute. For example, if you had some water and put a pinch of sugar in there, that's an unsaturated solution. You could still dissolve more sugar. There is no sugar sitting on the bottom if it's unsaturated, if you've sat there and stirred it long enough to get it truly, all of it to dissolve at will. So it's all dissolved, and there is no more solute left sitting on the bottom. It is all dissolved, so it's very clear. You can see straight through it. And if you add a seed crystal, which is an extra crystal of your solute, your solid that you're dissolving, then nothing happens. It just dissolves, because you could still dissolve more. A saturated solution has dissolved all the solute it possibly can. To prove that you could not dissolve anymore, there is still leftover solute sitting on the bottom. So for example, if you dissolve so much sugar in your water that you can't dissolve any more sugar, and there's leftover sugar sitting on the bottom to prove that it couldn't dissolve, that is a saturated sugar water solution. If you add a seed crystal, an extra crystal of sugar, it already can't dissolve anymore, so it just sits there in the bottom and doesn't dissolve. Next, if you have a supersaturated solution, now this is very different. It is very difficult to get sugar to supersaturate. So when I show you a demo, I'll show you a sodium acetate, which supersaturates very easily. But if we were going to get sugar to supersaturate, you'd have to have first a saturated solution of sugar. And there's leftover sugar sitting on the bottom that will not dissolve. That's saturated. Now, when you heat up the solution so that every bit of that sugar dissolves, it's not supersaturated yet, it's now unsaturated. But then you cool it back down so that the sugar should not stay dissolved. It should precipitate and form a solid and sit there in the bottom and be saturated again. But if all that extra sugar stays dissolved anyway, even though it shouldn't, and you cool it back down and the sugar should precipitate, but it doesn't. It stays dissolved, even though it shouldn't do that. That is a supersaturated solution. It looks totally clear. It looks just like an unsaturated solution. So how do you know that it's supersaturated? Well, if you add a seed crystal, if you put one crystal of your solute in there, then all of a sudden it causes all the rest of the dissolved particles to precipitate, or all the extra dissolved particles, to precipitate and make a solid that will not dissolve. And that solid falls down to the bottom of the container, and it kind of looks a little bit like it's raining maybe. Not always, but sometimes. And so that is a precipitate. And so when it all precipitates, because all the extra stuff was dissolved that shouldn't be, that is a supersaturated solution. Once it finishes precipitating, it's back to being a saturated solution. So if you see leftovers sitting on the bottom, it's saturated. If it's a clear solution, it's either unsaturated or supersaturated. And that's why you must add a seed crystal so you can tell the difference. If you add a seed crystal and it dissolves, it was unsaturated. If you add a seed crystal and it causes precipitation, it causes a solid to form, a solid to crystallize, then that was a supersaturated solution. Finally, let's talk about the difference between a concentrated and a dilute solution. A concentrated solution has lots of stuff dissolved in it. For example, if you put lots of sugar in your iced tea, that is very concentrated with respect to the sugar. It is a very sweet iced tea. Then, if you make a dilute solution, you put a little bit of sugar in the water, in the iced tea, and that would be a dilute sugar water solution. And so only a little bit of sugar is dissolved. This is a relative term. It depends on what you're comparing it to. So, for example, maybe your grandma's sweet tea is more concentrated with sugar than your mom's is. But maybe your great-grandma put even more sugar in there. And so hers is even more concentrated compared to your great-grandma's. Your grandma's sweet tea is diluted. And so it depends on what you're comparing it to. That's why it's best to use an actual concentration, a molarity. Molarity is the unit for measuring how concentrated something is. For example, a 10 molar solution might be very concentrated compared to a 1 molar. Or a 0.1 molar solution is diluted compared to a 1 molar. So concentrated and dilute aren't very exact, so therefore if you use a molarity, you know exactly how concentrated it is. And next, we will look at solubility curves. A solubility curve is a graph showing how much solute, how much solid, dissolves in 100 milliliters of solvent, your liquid, at different temperatures. So it shows how the solubility changes as the temperature changes. So we will look at that with the next worksheet.